So, welcome back student to the next class of complex analysis. In the previous class we mentioned very important concept of the integration. So, let me remind you once again that this is my function and this will be 0 when fz is analytic over that region and may not be 0 when the fz is not analytic. So, last day I mentioned that if fz is not analytic in some region, so how to find out the value of the integration, is there any way? So, indeed there is a way, it is called Cauchy's integral formula. So, let me first state that and then I will prove. So, the thing is Cauchy's integral formula. Let us go to the statement first, then I describe and try to prove how the things is going on. So, if we have, okay, let me draw it here. This is the region say C and a point here is A inside the region, then the integration, then the statements state that let me write it here, then I will explain. If fz, this is the statement, this is the statement of Cauchy's integral formula. So, after writing the statement, let me explain one by one what is the meaning of that. Fz is a function which is analytic in this region, right, but please note that this quantity, say I write z dz, this gz is fz divided by z minus a, which is not analytic in this region, please note that. So, here I have a function gz dx which is not analytic. If I try to find out the integration over C, then the value of integration will be just 2 pi I multiplied by f a, where f is an analytic function given here. That is the statement. The straightforward statement is, if fz is analytic over the region C and a is some point here, if I manage to find out the functional form in this way fz minus z minus a dz, then the this integration can be evaluated and the value will be 2 pi I multiplied by f a, that is the statement. So, now let us try to prove quickly how we can prove it. This is the statement. So, let me put this figure here, so try to prove it in this. So, first again z minus a, I put this integration C, and if I closed an circle here with epsilon radius, these two things are same. Last day we proved that. If you remember that gamma 1 is equal to gamma 2, we prove this. So, some integration over gamma, that means the bigger circle is same as the smaller inner circle if I put some smaller smaller circle inside this region. So, here these things and this small one is the same. So, now I put for this small circle which is the value of this which is same. So, I just want to evaluate this quantity. So, C, I just wanted to evaluate this quantity z minus a dz. This is the quantity I want to evaluate. Now, this is equivalent to, if I say this is my gamma, equivalent to gamma closed integral fz divided by z minus a dz. Fine. So, now I change this C to gamma because I have already shown that these things are same. So, for this integration now I am putting my variables like this. Okay. So, Z can be represented as we did it earlier one problem, that Z minus A is this quantity. So, what is my dz? Dz is epsilon is a constant, so I should not change epsilon, I take a constant thing, dz epsilon I d theta e to the power of I theta. This. Now, I just try to find out this integration, that is all. This integration over gamma is fz divided by z minus a. So, now I change this thing. So, z minus a is epsilon e to the power of I theta multiplied by dz. Dz is epsilon I d theta into e to the power of I theta. This e to the power I theta and e to the power I theta will cancel out. Epsilon is also cancel out. These things are not be there. What finally we have here? Fz now, since I put the value of z, so Fz is now a plus epsilon e to the power of I theta, this quantity, then I d theta. Now, after having this thing, we will put some kind of trick here. The trick is I choose this smaller circle gamma with some radius epsilon. You may choose another with a smaller epsilon, somebody choose another with a smaller epsilon, and so on. So, that means I can shrink this epsilon according to my likings, and it suggests that every time I will get the same result, because it never mentioned that it depends on the radius of this epsilon. So, I never mentioned, or the calculation never mentioned that epsilon should be some value for which this is. So, if I want to shrink this epsilon, and if epsilon tends to 0, then still the result is valid. Under this condition, because I need to evaluate these things and epsilon is sitting here. So, what I will do, that I will put the limit epsilon tends to 0 over this, and essentially by doing that I can eliminate epsilon, but this thing suggests that it will not going to change the entire structure. So, if I go from here to here, the value of the integration will remain same. So, I just put the epsilon, to remove the epsilon I just put this limit it comes like this. So, this is the expression I have in my hand. After that, what I will do, I will just put the limit and find out what is the value. If I put the limit here, then eventually I have close integration f of a, I will go outside d theta. Now, again this close integration, which is equal to I f of a, which is going outside, because f a is not a function of theta. After putting the limit epsilon tends to 0, this quantity is vanished, this one is vanished. When this one is vanished, we will have only f a in our hand. So, we will take this f a outside this integration, and then integration limit will be just 0 to 2 pi d theta, and this is nothing but, this quantity is nothing but 2 pi I f a. I erase this part. In the left hand side, what we had, the left hand side I had this quantity, because I started with this quantity. So, f z divided by z minus a integration dz is equal to 2 pi I f a. So, this is nothing but the statement of Cauchy's integral formula that I wrote the very beginning. So, f a is how much? 1 by 2 pi I integration f z z minus a dz. So, we prove this Cauchy's integral formula, and this is a very very powerful formula, because you can have now the everything in your hand. So, if I have this integration in my hand, I can readily find out what is the value of this integration. It is just 2 pi I multiplied by f a, if the region, if a region is given to you where f z is analytic. So, after having this expression, we now try to find more from this expression, and we do it in this way. If I make a derivative of this expression with respect to a, f1 a, so what value I will have? 2 pi I integration of f z dz. This quantity will be z minus a square. One negative sign will come because of this integration, but one negative sign is sitting here just before a. So, this negative and negative will be positive too. We have this quantity. Now, if I go on integrating, then I will ended up, if I have the nth order integration f n a, it will gives me simply factorial n divided by 2 pi I integration f z dz divided by z minus a whole to the power n. After doing the integration over this, I will have this. So, two very important expression is now in our hand, and this expression is, one is f a and another is f n a. If my functional form is something like this, where we have some kind of power sitting here, then I will use this expression with this. This is factorial n. So, it looks like h. So, let me change it. And if I have the function like this, I will use this. So, after having the expression in our hand, so let me just write the expression somewhere here and then start doing the problem. So, let me write this expression here for my convenience. So, f of a is 2 pi I total integration f z z minus a dz. This is one formula that I have, and another is f n a is equal to, okay, 2 pi I should be 1 by 2 pi I, 1 by 2 pi I factorial n divided by 2 pi I total integration of f z z minus a whole to the power n plus, okay, 1, I mean I do not know what I wrote here, it should be n plus 1, because every time when you do the integration, if it is n, so this integration when it was 1, so this integration was here, we have 2 here. So, when it is n, it should be n plus 1. I do not know, I erased that in the last expression, what I wrote I forget, but it should be n plus 1 anyway. So, this 2 is in my hand. Now, if it is in my hand, then I can readily calculate few integrations. So, let us do some problem straightway. So, let me check which problem I have in my hand. So, okay, so one problem is here. Example 1, how to calculate this integration. The problem is given as this function e to the power z z square plus 1 whole divided by z minus 1 whole square. This integration you need to evolve, where the contour, since it is a close integration, the contour is given to you and this contour is z is equal to 2. This is important. Every time the contour is very important, the over which contour I want to find out. Now, after having this expression, you can rearrange these things in terms of this. That is the first thing you need to do. So, if I do that, then I readily find here my fz is e to the power of z square plus 1. This is my fz. And what is my z minus a? Here z minus a whole to the power n. If you remember that this is square and we have something here. So, that means this square is nothing but z minus 1 square. So, a is here 1. Now, the thing is that first we need to check whether these functions, the entire function is analytic over this region or not. So, this region first we need to draw. Let me draw it here. Mod of z is equal to 2 means which region they are talking about? They are talking about a region, this is z equal to 0 and this point is 2, the radius is 2, this is radius of 2. Now, where is my a? Z minus 1 square. So, a is how much? 1. So, if a is 1, this point is sitting over here. This is the point 1, which is inside the region that is given. That means this entire function has a singularity at z equal to 1. So, that means this function is not an analytic function. So, close integral over this will not be 0. That is the first thing. Second thing is that once I have the singular point here, I will just going to apply the formula that I have. So, the formula is straightforward. Once you have, so the formula of this is straightforward. It will be f prime 1 into 2 pi I. I am using this with n equal to 1, because if I put n equal to 1, then this equation comes out to be this. So, these things I need to evaluate. In order to evaluate, what I need to find out? The function I need to evaluate, the derivative of this function, first derivative of this function at 1 I need to evolve, that is the I need to figure out, that is the thing. So, what is the value? So, function z is already I read in that it is e to the power z. So, function of these things is how much? E to the power z square plus 1 plus 2 z e to the power of z. If I take e to the power z common, then z square plus 2 z plus 1 e to the power z, or seems to be z plus 1 whole square e to the power of z. Now, if I put f prime 1, so this is my f prime z. So, f prime 1 is I just need to put it here the value 1. If I put 1, then this value, so let me erase this. So, this value comes out to be f prime of 1, it simply comes out to be, this is 1. So, it is 4 e to the power of 1, 4 e. So, now my total value is this. So, the integration is 8 pi I multiplied by e, that is the value of the integration that I wanted to find. So, total solution. So, this value, this equation, when I am evaluating it at z equal to 2, this region, that means this region, the value comes out to be 8 pi I e. Okay. So, this is the first problem. So, now after that we will go to few other problems. So, let me do that. I believe you now have the idea how to evaluate this kind of integration, which is very straightforward. Problem 2. Problem 2, using this, just using these two Cauchy's integral formula, either you need to use this or this. Example 2, the function, the integration is given as close integration z square divided by z square plus 4 dz. That is the integration you need to evaluate. This is the integration we need to evaluate, but before evaluating I need to know what is the region that is given. The region is given that z minus I is equal to 2. Over this region I need to find out my integration. So, before doing anything, first I need to just draw this region, what region they are talking about, and then I need to find out where the singularity is there, and accordingly I calculate by using that formula. So, first the region. So, let me draw the region here, this side. Z minus I is 2, that means my coordinate is somewhere here. This is the point I, and I will going to encircle this point with a circle of radius. I need to, this is my center. I need to encircle these things with radius 2. So, I, this is 1 unit, this is 2 unit, this is 1 unit, this is 2 unit, this is 1 unit, this is 2 unit, this is 1 unit, 2 unit. So, my circle will be something like this. Okay, just look a very bad looking circle. So, let me something like this. In this kind of problem, you need to know very precisely where you try to calculate what is the region and where you try to calculate this integration. So, now I know that my I point is here, and this is the region where this radius is 2, this radius is 2. Okay. Now, I simplify this expression, z square divided by z plus 2i z minus 2i. This is a familiar function, because in the previous class I have already mentioned this function z plus when I try to find out the singularity at two different points. So, now you have 2 points where the function is having some singularity. One point is 2i and another point is minus 2i. You need to find out in this region which point is inside this region. You can readily find that 2i point, this is I. So, 2i point is somewhere here, is inside. This 2i point is inside. What about minus 2i? Minus 2i is not inside, it is outside. So, this is I. So, here this is minus I. So, somewhere here it is minus 2i, which is outside the region. So, that means if I write this function, I need to now rewrite this function slightly modified way. So, z square divided by z plus 2i whole divided by z minus 2i dz, then I have the form. So, now this fz is analytic. Here if you remember, I mentioned that my fz has to be analytic, total function may not be analytic or should not be analytic, because some singularity will be sitting here, Here I am writing the functional form in this way. So, what should be the value here? The value will be function here, function of z is how much? This quantity z square divided by z plus 2i. I just replace this function. So, it should be function at 2i point multiplied by 2 pi I. Function at 2i point means how much? Z square is 2i square divided by 2i plus 2i, it will be 4i, then it will be 2i 2 pi I. So, here I will have one negative sign will come because of this square I square. So, 4. So, minus of 4 divided by 4, this I cancel out and 2 pi. So, we will have minus of 2 pi. So, the result here is minus of 2 pi. So, this integration, if I solve this integration results, the result is minus of 2 pi. Before concluding, let me give another simple example and then I will going to conclude today's class. So, quickly another example, the similar kind of example. So, example 3. Example 3, the function is given as 2z plus 5 divided by z square minus 2z, and the region that is given is mod of z is equal to half. Mod of z is equal to half. This is the expression. So, mod of z equal to half, what region they are talking about? Quickly we should draw. Mod of z equal to half means this is 1, this is 1, this is I, this is minus I. So, half means it is encircling something like this, where the radius is half, and this is z equal to 0 point. Now, here how many singularities are there we need to find. So, 2z plus 5 divided by this is z multiplied by z minus 2. So, obviously, one singularity is at z equal to 0. So, z equal to 0 we have one singularity and z equal to 2 we have another singularity, because at these 2 points the function blow up. I need to put a dz here. But my region suggests that z equal to 2 point is outside, z equal to 2 point is somewhere here, this is z equal to 2 point, because this is 1. So, somewhere here. So, it is well outside the region. If it is well outside the region, then my but z equal to 0 point is inside. So, z equal to 0 point is inside here. So, I can rewrite this function, this integration like this, 2z plus 5 divided by z minus 2 divided by z dz. What will be my answer? My answer will be 2 pi I multiplied by the function, whatever the function I have at 0 point. So, which is 2 pi I, this function at 0 means I have 5 by minus 2. So, my result will be minus of 5 pi I. So, this is the result. Okay, with this small few examples, I would like to conclude my class here today. So, today we learned a very important concept, that how by using Cauchy's integral formula you can evaluate the integration like this at some region. You need to find out the points at that region, whether these points are giving some kind of singularity or not. For here in this case z equal to 0 point is a singularity, and you rearrange the function in such a way you can use these expressions, whatever the expressions is given to you, which is the basically the recipe or formula to calculate the integration, and then you do straightway what is the value of that. So, with this note, let me conclude the class here. See you in the next class, and thanks for your attention.